Hello everyone, in this module we are going to be covering web applications and their architecture. But before jumping into web applications, we will first of all be seeing what is the difference between web applications and websites. Are they even same or are they different? So you should be knowing the difference between both of them. So websites versus web applications. Alright, so when you talk about websites, so typically they are going to be having some static content. So when you talk about some static content, what does it mean? It means that content which is going to remain same and that is not going to change unless we are doing some manual updation or that. And in this one, we are only going to be providing the access of read. If you talk about some newspaper website, so those ones are majorly static because they are going to have some news and all you will have to do is to go through that. So I hope it must be clear to you that what do we actually mean by static content. All right. Now the next one which we have here is web application. So when you talk about web application, here we are going to be having some dynamic content. When you talk about dynamic content, it means whatever the content we have here, that is going to change in the real time. And this is also going to be user interactive. So here we are going to be providing the read plus write, both of the accesses. So that is how the web applications are going to be there. Now I'll just list some of the examples for both. So when you talk about websites, just I took one example, that is going to be something like newspaper. Example, Times of India or any other. Okay. The other one could be something like Wikipedia. Although you can go ahead and change the content, but for that you will have to make a request. You will have to add a page there. That is how it is all going to be working. But in general, Wikipedia is all about reading the content. Also some blog posts. So blog posts were also quite popular, and in that one what people were doing, they were just writing down everything there. So as a user, what you were doing, you were just going through that, reading, going through the pictures. So all of that was static content, you were not modifying it. So that is the example of your websites. Now let's quickly discuss some of the examples for the web applications. So it can be something like Gmail. So here if you will see, you will be having the flexibility of composing a mail, sending a mail, based upon, like, if you are composing and the moment you are going to send, in the real time itself, it will get sent. Other example, if you talk about some social media like Facebook. So there, in the real time, you can see who is posting pictures there. You can chat in real time. You can like the statuses and posts in real time. So all of those things are happening in the real time, and that is user interactive. Like you are also interacting with that. Okay. Another example could be something like LinkedIn. So in the LinkedIn, what happens? You are going to be having the flexibility where you will post about your milestones. You can see what other people have posted. You can interact with the recruiters, your friends and whatnot. So that is how it is going to be there. So here, like, if you talk about static content, what we actually mean by the static content. So static content is going to be that information which is read only. And this does not change based upon the user interaction. For example, some text or images on the web page that remains constant until the page is updated by the website owner. So typically that is how it is going to be there. Also, like, if you talk about creating a basic web page using HTML, so that is also somewhat similar because there we will be putting all the static contents like image we are putting, table we are putting. So all of that is going to be coming inside your static content. On the other side, if you talk about the dynamic content, what will happen? You will be having access for both read and write operations. You can read the content as well as you can interact with it. You can update it. You can also add new content. So based upon the requirement, you are interacting with that. So that is how your web applications are going to be there. And majorly in today's date, we are using web applications. Although we are still using websites, and like, they are still going to be there because of the use case. Like they offer a different use case, and for all of the scenarios, like we are not going to be having always the dynamic content, correct? So if you talk about the past, like, websites were primarily static only. Initially, when internet came and all, majorly we were using static content there. Mostly we were performing some read operations. So whatever the content which was available to us, that was read only content. If you talk about the early websites, so majorly those were informationals, and you could not interact with them beyond reading. You were just extracting the information, reading, and just that's it. So that's how initially the concept of websites were introduced. However, if you see today, most of the websites have evolved into web applications. So these are dynamic and they allow for both reading as well as writing. So if you take the examples of like Gmail, Facebook, LinkedIn, so they all are allowing you to read the content, to post status updates, to share pictures, and perform many other interactive tasks. So if you talk about any platform where you can dynamically change or contribute the content, that's what we call as web application. On the other side, like, if you talk about websites, so these websites are primarily used for reading purpose only. So if you take the example of Wikipedia, news websites, blogs, so here if you will see, the main interaction is consuming content rather than creating it or modifying it. So these are typically read only platforms. That means the user cannot significantly alter the content. User cannot change the content, and they are categorized as websites. Now we can actually have a question that in future, can I replace all the websites with web application? Now you guys can actually think about it. The answer is yes. In future, or if you talk about present, we can replace all the web applications, all the websites with the web applications. But ideally, we should not be doing that. So technically, like, we can replace websites, but that is going to be overkill in many cases. Websites are often simpler, static, and they serve different purpose as compared to web applications. So example, like, if you only need some read-only content, like writing poem, blogs, or displaying some static information. In such a case, a website is more suitable. A dynamic web application is not necessary in such cases. In such cases, a website is sufficient, more efficient, and ideal for showcasing the static content without requiring some real-time data or it in complexing the like making the entire user interaction complex. So that is how it is going to be there. When you talk about websites, so websites are actually serving as a digital repositories for the information. So think about a piece of paper. Like, if you are storing some of the information on a piece of paper, over the period of time, it may tear, it may fade, it will get damaged, it will become unreadable, or it may even get lost over the period of time. On the other side, if you talk about website, since it is a digital repository, we have the option of preserving the information for long term. And considering this, websites are still going to continue. They are still going to exist in the future for the situations when we only need static content, when we only need read only content. When read only content is going to be sufficient, we are going to go ahead and use websites only. Now we should be knowing when to use a web application. Okay, this is what we are going to be discussing. So when you talk about web applications, so web applications are needed when you want to solve some real life problem. So if you are going to be solving some real life problem, so that is also going to be involving some dynamic interaction. Correct? So if you talk about, like, let us say some web application is there, and that web application is letting us perform some of the actions based upon our inputs and based upon whatever our requirements are there. But that is something which you cannot do on some static websites. Example, if you want to buy something, Where you will go? You will go to platforms like Amazon, Flipkart, right? If you want to travel, where you will go? You will go to Ola, Uber. If you want to buy medicine, where you will go? You will go to 1mg, Practo. If you want to communicate with someone without leaving my home, so there you will have some dating websites. If you want to interact with your friends, so you are going to be using Facebook, you are going to be using Instagram. So all of these things you are going to be using. So you need to understand what your problem statement is, and accordingly you are going to be taking a decision on the top of that. If you talk about the today's world, so everything can be actually done by web application. Be it your shopping, communicating, traveling, managing tasks, anything. So for everything, we are actually interacting with the web applications every day. As the internet continues to evolve, web applications will always remain central to how we live, how we work, how we interact online. So today almost everything that everything we are doing through web application, which is letting us interact, transact, solving problem in a way that static websites cannot. Now you need to understand why web application is essential. So let us say you are planning, if you are already working in some tech industry, it is very important for you to understand that most of the companies are building or maintaining web application. So whether you are working as a front end developer, back end developer, or a full stack developer, you are going to be contributing to the development of these web applications only. So that is why understanding the architecture of web applications is very important. Okay. So when you talk about web application, so every web application has a front end and a back end. When you talk about front end, so that is your visualization layer. All right. So this is where the user is going to see and interact. Here, what and all you are going to be using? You are going to be using something like HTML. With the help of HTML, you are going to be if you want to structure out something, you are going to be using HTML. If you want to add some styling, you are going to be using CSS. If you want some interactivity, so with the help of JavaScript, you are going to be adding that. When you talk about some of the JavaScript frameworks like Angular, React, so what of these frameworks are actually doing? So they are helping us in building some interactive and dynamic user interface. So when you talk about front end, so front end is actually all about creating some engaging, responsive experience for the user. So that is how it is going to be there. So if you talk about any of the web application, here broadly we are going to be having three things. Okay, any of the web application is broadly going to be having three things. So the first one is going to be the front end. This is also called as your visualizing layer. The second one is going to be the back end. Back end is going to be the business layer. That is where you are going to be putting the core logic. And lastly, you're going to be having some data storage layer. So whatever data you are going to be requiring, all of that you are going to be storing and managing here in this layer. Okay. When you talk about front end, just now I have listed some of the technology. So what and all you are going to be using here? Let us say HTML for structuring out, CSS for the styling. You're going to be using JavaScript in order to have the interactivity. You're also going to be using JS frameworks like your Angular, React. So that is all you are going to be using here. And in this case, like there is going to be someone like this person is going to be there who is going to take care of all these responsibility, and we generally go ahead and call them as front end engineers. Okay. Now, when you talk about backend, so here what and all responsibilities we do, we build the core logic, and we build that in some of the languages like your Java, C Sharp, C++, Python, and so on. And for doing that, you will be having some set of person who is going to be taking care of all these responsibilities. And that one we go ahead and call as backend engineers. Then for the data storage layer, we are going to be making use of like file-based storage system. We are going to be having database management system. We are going to be having relational database management system. We are going to be having NoSQL, and the guy who is going to be taking care of all these responsibilities, that we go ahead and call as DBA, database administrators. Now you have seen like, we have three different layers and we have three different person who is taking care of all these responsibilities. We have one more, that is something which we call as full stack engineers. And these are the ones who take care of the responsibilities which a front end engineer does, as well as the responsibilities of back end engineer. So that is all this person is going to be doing. Okay. So like, when you talk about any web application, you should be knowing that here we are actually going to be taking care of the visualizing part, the backend logic, and the storage part, because we are going to be also like, this data is something which is getting very like, this data is something which is evolving every day, and for that we actually need to find out some procedures so that we can go ahead and store them and compute them efficiently. When you talk about backend layer of the web application, so that is where you are going to be like, this is something which we also call as business layer, and this is responsible for writing the core logic. The data management of that application is also important, and that is where like, you are actually going to be taking care of this data storage layer. So this one is going to be performing all the complex computation and all the other processes which we require to run the business. It's that part of the application that the user does not get to see. Like, if you are, let us say, opening Gmail, so all you can see the front end. There you will be entering the username, the password, and you will just click on login. What is the logic, the core logic that has been happening behind that? That is something which you are not going to see. So backend is something which generally a user is not going to be seeing, but this plays the most important role in its functionality. So this layer is basically responsible for crunching and munching of the data. And this one is going to be providing all the necessary information that your back front end needs to function properly. Like after computing, it is going to be providing you the value, and we are going to be displaying that on our screen. So this like, whenever you talk about the front end, so this one is going to be requiring some data, some text, some images, some news feed, and that data is going to get fetched and delivered by the backend only. So we are going to be writing the core logic in the backend. So this backend, we also call it as brain of the application, because it is actually processing the user request, it is running the business logic, and this is also serving the data need for the front end to display. What technologies which we use in the backend, like, we have various programming languages, various frameworks. You can go ahead and use any like any of the applications based upon the requirements. Some of them I have already listed, and some other are also there, like Ruby, Node.js, and so on. So these languages we are going to be using so that we can build APIs, we can handle database operations, and we can manage the overall business functionality of the web application. And all of those things are possible with the core logic which we are going to be building by using these languages. Correct? Now, this data storage layer, right? So when you talk about the data storage layer, so in any of the web application, data storage is going to be the critical component. Without having it, the application is going to be incomplete. So there are various approaches for storing your data, like file-based storage. So like, what happens, like the name is suggesting here, we are going to be storing our data in the forms of file. And we generally use this kind of storage for our simpler or smaller data sets, where we can store our data in files, some flat files, logs, something like that. Okay. Then we are having DBMS, RDBMS, like your relational database management system. So we are going to be having systems like, MySQL, Postgres, SQL, Oracle. So these are going to be storing our data in the structured table. So this is also going to be enabling your complex queries and relationships. Now the next one which we have is NoSQL database. So here we are going to be having systems like MongoDB, Cassandra, Redis, and all of these things are going to be handling unstructured, or you can say semi-structured data. This one is going to be providing you a lot of flexibility and scalability. A lot of people also get confused by the term NoSQL. They feel NoSQL means something which is opposite to SQL, but that's not the case. What NoSQL does, like, we have certain capabilities of the SQL, and whatever SQL cannot do, that we are doing with the help of NoSQL. So we can say NoSQL completes SQL there. In this one, we can have some unstructured data, like you talk about, let us say Flipkart. So there you will be seeing we will have multiple products listed there. All of those products are going to be having different set of parameters. If it is some beauty product, so we will be having some different attributes there. If it is some electronic, we will have some different attributes. If it is some food item, we are going to be having different attributes for that as well. If you will see, all of the attributes are going to be different in the terms of count as well. So that is something which we refer as unstructured data. And in order to implement that in the coding, we are going to be using NoSQL there. Okay, so I hope this must be clear to you. Now we are going to be discussing the different architectures for the web application. Now we are going to be discussing the different architectures for the web application. Different architectures for web application. So, here we are going to be having different architectural approach, which we are going to be using for creating your web application. And the first one, which we have here, is going to be called as monolithic architecture. So let's discuss what monolithic is. Okay. So like, here if you will see, we have like, when you talk about this word monolithic, so this is actually made up of two words. The first is mono, and what is going to be the meaning of mono, which is going to be telling one or single. Correct? So when you talk about one or single, that means here everything is actually going to be defined in one unit. So in this one, like I said, we have three major components: your front end, your back end, your DBA. So all of that is actually going to be there as a part of one single unit. So that is what your monolithic is actually going to be meaning. So when you talk about web applications, like, if you talk about in the context of web applications, so monolithic architecture means a design where all the components, your front end, your back end, your DB, all of those things, all of those things are actually going to be there in one application. So here if you will see, these all are tightly integrated and they all are actually going to be running as a single unit. Okay. Now when you talk about monolithic application, here what will happen? Everything is going to be part of one code base. All of the layers, your front end, your back end, your database. So all of these layers are going to be existing together in the single application. This means your front end, your back end, your data storage, all are going to be bundled up together in a single application. So this application is typically going to be deployed together, and this is going to be running on the same machine or server. So when we are going to be having code, so the code for all the parts of the system is going to be as a part of one code base. So that is going to make it easier to develop and maintain it in smaller applications. But here, if you will see, it is harder to scale the application as it grows because everything is there in one code base. So it's not going to be easy for us to scale when your application is growing. In monolithic architecture, everything is going to be together at one place. So what we can say here, we are going to be having single code repository. Okay, what can that mean? There can be different files, but the repository is going to be same. And in this one only, we are going to be putting all of the front end, back end, and data storage at one place. Now let's take example of some monolithic application. So, let's take some of the well-known application. So, let's take the example of, let us say, LinkedIn, or you talk about PayPal or the Facebook, like any application. So, initially, all of these applications were actually built using monolithic architecture only. So, even if you talk about Facebook, so initially, if you know, the Facebook was initially built on PHP, and this PHP was providing support for your front end and the back end, and also the DB. With the help of PHP only, we were trying to do all of these things. So in this setup, we can say PHP handled everything in one integrated system. And that's how it made Facebook as a monolithic architecture. So all of those things were actually taken care in single code base. So similarly, if you talk about Java. So Java, if you want to create front end, you have something which we call as JSP, Java Server Page. If you want to use the back end, for that you have Java Beans. There you can write down your core logic. And if you want to have the data storage, so for that you will have relational database. So this way we can say that if you are like building any monolithic application, there if you will go ahead and use Java, then also you can go ahead and achieve a monolithic application. So Java can also be used to create monolithic application where everything is going to get handled within one environment or one framework. I hope this must be clear to you. Now we are going to be seeing the advantages of the monolithic applications. Plus, we are also going to be discussing the scenarios where monolithic is actually going to be making sense. So the first, so whenever you are going to be starting any new application, so you may not be knowing what architecture to choose or which one will be the safest for the long-term success. If you are having that level of uncertainty about the future of the application, or if you have limited resources, in such case, monolithic architecture can be a great choice because initially when you are setting up any of the application, you do not need some complex architecture. You need everything which is very simple and everything lying at one place so that it will be easy for you to maintain. Now, what is the first advantage of using monolithic architecture? That is fixed boundaries. And you can say along with the fixed boundaries, this is also helping you in allocating the resources in a simpler manner. So okay, So when you talk about monolithic applications, so in this one, we are going to be having fixed boundaries. With that, it makes us easy for us to manage the resources. Let's just, uh, I'll take some examples so that we can understand this concept. Okay. So like, if you talk about PM of some company, PM of some country. Okay. Now, this one is going to be surrounded by various guards for the safety. Okay. So now, uh, if like, let's say that we are having different other PMs as well. So every PM is going to be surrounded by different guards, right? If this is PM1, different guards. If this is PM2, this is different guards. If this is some PM3, some different guards. Okay. So now let's imagine, like, here we are saying this is the PM of the country. This PM of the country is surrounded by team of some security guards. So if there is only one prime minister, it is easy to ensure the safety because there are fixed boundaries and we have a single point of focus, because we just know that, okay, we have one person whom we want to safeguard. We can deploy our entire security on one place and we will just be putting our major focus there. However, if we are having multiple prime ministers, correct? So in that case, managing security is going to become complex. In that case, we are going to be needing more guards, and dividing the security forces is actually going to be compromising the safety of each prime minister. Like here, if you will see, like let us say here we have six guards. Okay. So if you will see in this case, what is happening for one PM, we have six guards. And if you will take this, we have two guards each PM. Correct? That is what is having. So if you will see in this case, what is happening? We are compromising the safety of each prime minister. So, like, if we will just take this in the form of our application, so you can consider this PM is nothing but our application only. And when you talk about security guards, so these are nothing but our resources. These resources are like something like developers, your time, your infrastructure, it could be anything. So if you have multiple separate applications like the microservices, in that case, you are going to be needing more resources to maintain and secure each one of them individually. Correct? Just how we have seen here, like if everything was at one place, everything was only focused at one place. But when we are having it for different prime ministers, everything got divided. Correct? In that case, security got compromised. So similarly, if we are having separate applications for everything, so for every, like, every application is going to be requiring some of the resource, and it will become difficult to maintain and secure each one of them individually. However, if we are having monolithic application, if everything is going to be there in one place, in that case, we can put all our focus, we can put all our resources in one application. And then it will be easier for us to even secure and maintain it. So when we talk about monolithic applications, so these are generally more secure because there is only one system to monitor and protect. So rather than multiple, where everything, every component is at different place, instead of that, we can keep everything at one place, and that is where we can put our all resources. Okay. Now, what is the second advantage of monolithic application? When you talk about communication, so for there we are going to be needing latency. So monolithic application offers lower latency and faster communication. All right. So what actually happens here, we are going to be having everything at one place. Our front end, our back end, our data storage. So all of that is at one place, right? So what will happen, since all the components are hosted on the same machine, so this will allow direct communication between the front end, back end, and database. In this one, if we want to interact with all the services, we do not need network for that. Without the need of network, we can still go ahead and communicate between the separate services. So this, here what we are actually using. So we are using method to method communication, because in that application we are going to be having separate methods, and every method are just going to be calling each other. And this is also called as IPC, where it stands for inter-process communication. Okay, that is how it is going to be there, because here what is happening, everything is in the same system. So that is going to be reducing the overhead of network calls. And if there are no network calls, so if we are going to be retrieving some data, if we are going to be processing some data, so all of that is going to be extremely faster. So certain times we create some applications which are latency sensitive. What do I mean by that? Sometimes we have some of the applications where we require lower response time. We want responses very quickly. So in such a scenario, monolithic application is ideal. This is going to be serving our purpose, because here there is no network latency between the different parts of the application. We are not going to be requiring network in order to perform the interaction. Since everything is at one place, so interaction is going to be quicker, and that is going to be making our monolithic applications well suited for those applications where performance is critical. So for the performance critical applications, we should always be preferring monolithic applications, because these are going to be giving you results extremely fast. Here the results are going to be super fast. Now let's discuss the next advantage of monolithic application. So the next advantage is easier integration testing. So since here everything is at one place, in this we are going to be bundling our front end, back end, everything at one place. So in this case, whenever we will have to perform integration, that is going to be a very straightforward process, right? And when we will have to perform some integration testing, so that is also going to be straightforward. In this one, we are going to be testing interactions between your front end, back end, and the database. And all of that can be actually done at one place. We do not have to worry about complex inter-service communication or any of the network failures. Generally, when we are hosting our entire code base on different machines, what happens, we are going to be involving network, and in such a case, if network is not up, if we are facing any of the network failures, so in such a case we are not going to have our application in the working state. But here, if you will see, we are not involving any network. So the network failures are not at all going to be there. So this is going to be making our testing faster, simpler, and less error prone as compared to our distributed systems like microservices. So here, when you perform integration testing, so that is going to be just like, involving different components, like, all the different components written in that same application, in that same code base. So it will be easier for you to go ahead and perform the integration testing. The next one is going to be less confusion for developers. So, this is something like, we generally do not put more attention to it, but this is one of the major advantage of using monolithic application, that it reduce confusion for developers, especially in such a team where we have varying level of experience. So if you talk about the real world, so not all the developers are going to be equally skilled, or not necessary that they all are going to be staying up to date with the latest technologies. Some may be less familiar with the modern practices or the new architectures, and this can actually result into slower deployment or more mistakes. In such a situation, like what will happen, like let us say we have our front end written in some other tech stack, backend in some other tech stack, and let us say not every developer is well versed with all of those things. In such a case, it will be little difficult for them to cope up with all the requirements, right? So in such a scenario, mistakes are also going to be there, right? But if you talk about monolithic architecture, so that is a practical solution because it is simpler to understand. Since everything is part of one application, so developers do not have to worry about learning multiple systems or technology. They can just focus upon one code base and they can understand entire application more easily. Plus, when you talk about monolithic application, so it is more accessible. So develop, like if you have developers and if they have less experience, or if they are not keeping up to date with the latest trends, still they can contribute effectively because the learning curve for the monolithic systems is typically lower as compared as complex architecture. Correct? So if you talk from a productivity perspective, so if developers are spending less time getting up to speed with the system, so they can deliver features and updates more quickly. And this can especially be valuable for small teams or organizations where we will be having some limited resources. Understood? Now we are going to be discussing what are the disadvantages or the challenges of monolithic applications. So here, like, when you talk about monolithic application where everything is actually built in a single unit, so they can have some benefits, but they will also come with some of the challenges because here, when you are going to grow as your application, in such a case, it will become hard to manage. So let's see what and all are the disadvantages. So the first one, which I have just said, that it will be difficult to maintain. Okay, so like when you talk about your monolithic application, as they are growing in size and complexity, it will become harder to maintain. So when you talk about multiple developers, so when these multiple developers are working on the same project, they might accidentally make changes that conflict with each other. Example, we have some, sorry, yeah. So example, we have some developer A here. Okay, this person is actually making some changes in the backend. Okay, now we have another developer here, developer B. This person is making changes in the backend, sorry, in the front end. So if these changes are not working together, what will happen? In that case, we may have certain problems, we can have certain conflicts as well, right? Now, if we will have more people working on that project, so that is going to be creating more conflicts, and then it will become very difficult for us to manage and fix that code. So this is a code conflict, and this is a very common problem when we will be working in a big monolithic application. So this is essentially common when we will have different parts of the application which are tightly coupled. So in that case, tracking dependencies, maintenance, and understanding the entire code base can become difficult because what will happen, like, we will be having one project. For that project, we are going to be having multiple people. And if all of them are contributing to it, then we are going to be getting code conflicts, right? So that is what is going to be there. Now let's discuss the next disadvantage of monolithic application. So that is going to be slow deployment. Now, how are we concluding that it is going to have a slow deployment? Like, when you talk about monolithic system, so everything, be it your front end, back end, database, so everything is going to be there in one big application. This means even if there is a small change, like, changing the color of the button, so that is going to be asking you to redeploy the whole application. Let us say for this application, you are in the CSS, you are just changing the color from blue to red. So even if you will see, this is just a small change. But for that also, you need to redeploy the entire application again. So this can take a lot of time. Like, generally the deployments are going to be taking somewhat around 30 minutes of time or even more. So even for a single change, even for a very, like, one word change, then also you are spending your 30 minutes, right? So what will happen? This is going to be slowing down the entire process of releasing updates. And especially when your application is going to grow bigger, in that case, it will be even difficult for us. Now, the next disadvantage is going to be your longer time to production. Or we can call it as less flexible. Okay. So what happens, like, when you talk about a monolithic application, so here your front end, your back end, your data storage, all of that is going to be there at one place. And what will happen? It is actually going to make your entire system tightly coupled. Correct? So what will happen if applications are tightly coupled? This means the small change in one part of the system can create issues in the other part. And because of this, every time something changes, in that case, you will have to test the whole system in order to ensure that nothing is broken. Correct? Let's just take one example here. Let us say this is a developer A. Okay. And this developer A is working on the backend. Then we are having a developer B, and this developer B is, let us say, working on front end. Now, this developer B wants to make some change, but he is waiting for the developer A to complete the change. That can be like, vice versa as well. So they are kind of waiting for each other to finish off their work. Now, there can also be a situation that developer A needs something from developer B, but developer B is busy. So developer A might be stuck waiting for that. So what will happen? This is going to be slowing down the development process, and this will make it harder to quickly make changes or release new features. So as a result, we can say monolithic applications are usually less flexible and they are harder to adapt to the new requirements. That is why we can say monolithic applications are going to be less agile. Now, what is the next disadvantage? That is going to be the single point of failure. Single point of failure. Now, what does this mean? Since everything here in the monolithic application that is going to be running together, if one part of the system breaks, then entire application will stop working. For example, let us say there is some issue with the database or there is some issue in the backend. This can make the whole application crash. Even if the other parts of the application like front end are working fine, but the system will go down because everything is linked together. So this is a big problem, especially for those applications, those are up and running all the time. Like example, payment system or some banking application. So in such a case, if one thing goes down, the entire application will be down, right? But will it be okay? Like, if I want to use some banking application and it will say, I am not available and I don't even know for how long it is not at all going to be available. That is something which is not desirable, right? Similarly, for the payment system, if you are outside and if you want to make payment, but that is down, that is not something which anybody would be liking. So for such places, monolithic applications are not good. But here, if you talk about microservices, where application is split into smaller independent parts, they are better at handling these kind of problems. Now we are going to be discussing, can we scale monolithic applications? So the question is, can monolithic applications be scalable? So just everyone pause your video and think about it. What do you think? Can we scale monolithic applications or not? Since here everything is bundled up at one place. Okay? I'm sure you guys must have paused the video and tried to think about it. So the answer is yes, monolithic applications can be scaled, but there are going to be certain challenges. Those are going to be coming with scaling. So let's break it down. Let's take the example of Times of India. Now you know this Times of India is a monolithic application. Correct? Now, when it was first built at that particular time, this app was designed to publish some basic news. All right, and that is like you're just printing some logical news, and that is something which is limited to a small audience. But in early days, not many people use that application, so it all worked fine with a smaller user base. But now, if you will see, like even if everything was at one place, so it was all okay because previously we had less number of users for that. But if you talk about, like let's say some intern is joining the Times of India. Okay, now let us say this intern has some great idea. He's saying let's add some spicy news as well. So previously we just had some basic news. Now he's saying let's add some spicy news as well. What do we mean by spicy news? Something like some gossip, some sensational stories. And he also said that okay, like previously we just had some of the basic news. Now let's add some images as well. And let's try to just make some content more engaging. So this idea was something which everybody in the organization liked. So this idea quickly became popular. And initially, like if let us say previously we just had a smaller code base, smaller user base. Now that grew with time. So now we are having more number of users. Now, what actually happened when more and more people started subscribing to it? Times of India saw huge growth in users. As the number of users grew, Times of India started facing problems. The application was not built for that level of traffic. It was designed for a much smaller user base. So the application could not handle the increased load. To handle this, Times of India moved from using one server to using multiple servers. So previously we just had one server where everything was deployed. Now they are using, sorry, now they are using multiple servers. So we are using multiple servers so that we can share the load. And there is absolutely no problem with this approach in the monolithic application. So previously, when this place had all of those three components bundled up at one place, your front end, your back end, your DB, everything was there on one machine. Now, instead of keeping it only at one machine, we started using multiple servers, which means now you're having multiple machines. And like when you perform such kind of splitting, like instead of keeping everything at one place, now we are making use of multiple machines. So this is what we go ahead and call it as horizontal scaling. So when you talk about horizontal scaling, what does that mean? It means spreading the load across the different servers. And when we try to do that, what we do, instead of keeping everything at one place, we are now going to be keeping it at multiple places. So this is definitely going to be helping with scaling the application, especially if the number of users are growing. But there is a catch. While horizontal scaling helps, but selective scaling is not possible in monolithic application. Selective Okay, so why that is happening? If you talk about Times of India, so that is mostly read-only application. Here, the content means the news that does not change much after it is loaded on the front end. So even though we have more number of users, even though we have increased in the number of users, the backend part where we are writing the business logic and the data processing logic, so that part and the database, they are not getting any bigger load because that is still going to remain same. The load was mostly on the front end because more users were reading the news. So ideally, Times of India, they would have only scaled the front end so that whatever the increased traffic is there, they can go ahead and handle that while keeping the backend and database same. But since this is a monolithic application, so everything is bundled together. So even if you want to scale one part, that is the front end here, you are scaling the entire application, including the backend and database. So even though we were not having heavy load on the backend and database, still we were scaling the entire application. As a result, what will happen? Here we are going to be experiencing higher cost and complexity. So instead of scaling that part where we needed it, we are scaling the entire application. So what is the main challenge here is that we cannot go ahead and scale the monolithic application. Like if you want to do only one part of the application selectively, like if we are selecting, like, okay, I want to scale the front end or if I want to scale the back end, that is something which is not possible in the monolithic application. With the monolithic application, everything is tightly coupled. So you need to scale everything together. So even if only one part needs more resources, then also we are scaling up the entire application. So what will happen? This is going to be resulting into inefficiency and higher cost. In order to solve all of these, we are going to be coming up with the another architecture. So the first architecture which we have discussed is the monolithic architecture. Now we are going to be discussing another. So that is going to be the SOA. SOA stands for Service Oriented Architecture. Now what happens in SOA? So in this one, we are going to be here our application is going to be having a clear separation. So here we are going to be having one part which we call as service requester. And the other one we are going to be having which we go ahead and call as service provider. So these are the we are actually having two things here, the service requester and the service provider. So when we are designing service oriented architecture, what we are doing, we are designing our applications in such a way that they can communicate with each other over the network. Like the service requester and service provider, they both are going to be there on the network and they both are going to be communicating with each other. So if we want to perform any of the operation, So they both are there. These are the key components of our SOA. Okay, and if they want, they are going to be communicating with each other over the network. So here, if you will see, if you want to have any kind of communication, this is the setup which we are going to be using here. Now, what is the service requester? So, this is actually going to be requesting for a service or some functionality. So when we talk in the context of service-oriented architecture, the service requester is going to be sending a request to the service provider over the network. As a as a request, it is going to be sending it out. And what service provider is going to be doing, it will receive the request, and then it is going to be providing the requested service or the functionality. So after receiving a request from the service requester, the service provider is going to process it and send the result back to the requester. So when we talk about the SOA setup, so both your service requester and the service provider, they both are going to be having their separate code base. So we are going to be having some different set of codes there, and they are going to get deployed on the different machines. That is how I have even represented it here. When a service requester is going to be needing something, it is going to send a request to the service provider over the network. The service provider is going to process the request, and it is going to be sending the response back to the requester again over the network. So if you will see, both are communicating with each other over the network. So if you talk about it, so what it is, this is a system where we have two separate entities which are communicating with each other in the form of request and response. And how that communication is happening, it's all happening over the network. So if you talk about SOA in real life, I'll just give you one example here. You guys can also think what and all it could be there. So if I talk about me. So right now, if I talk about this scenario where I am a teacher, you guys are the students. So I am actually providing you a service. So I am the service provider. I am explaining you this concept to you, correct? And you guys being the students, you guys are actually going to be the service requester. Correct? So if you will see, you guys are requesting for a service. What is that? You want to have knowledge on the system design from me, and I am providing that knowledge. Means I am providing that service back to you. So we all are connected over the same network. In this case, internet. Correct? So we all are connected over the internet, but you can just see that. Okay. Here, this is the scenario. But if you talk about the another scenario where, let us say, this is me and I am having a house help here. Now, in that case, if you will see, I will become the service requester and they are going to become the service provider. Now, how it is actually going to be there? So when my house help is going to arrive at my home, I will become the service requester because I need their help. And they are going to become the service provider because they are providing service to me. So depending upon the situation, the same entity can act both as a service requester and the service provider. Now we are going to be discussing some impact of SOA. So when you talk about SOA, what impact it is going to be leaving on some web application. So when you talk about web application, how the layout is actually going to be there. So you are going to be having some front end, you are going to be having some backend, and you're going to be having some data storage. Now, all of these things are going to be connected over some internet, correct? But we can say they are going to be connected over some network.
That is how basically it is going to be there, right? So when you talk about a typical monolithic architecture, so what will happen in that case? Everything is going to be bounded together in one single unit only. Here we will have our front end, back end, and data storage. So that is how your monolithic is going to be there, correct? So if you will say here, what do we have? We have some tight coupling, correct? Because here everything is bounded in one single unit. So in this case, generally, that is not something which is encourageable. Nobody advises you to keep everything in that form because tightly coupling is something which nobody prefers. So in this one, everybody will say that instead of keeping everything at one place, why don't you break it down? So what SOA said that let's just separate out the front end. So whatever the user is seeing, keep that part separate. How the application is working, the core logic, the backend, keep that one separate. The placeholder where we are keeping our data, the data storage, we are going to be keeping that one separate. So all of these three things we are going to be keeping separate. And each of these part are going to be having their own code and we are going to be deploying all of them separately. So these are going to be independent from each other because we are keeping every part separate. Now, what is actually going to be happening? So this is going to be making it easier for us to update or change one part without affecting another. If here I want to make some change in the CSS, if I want to change the color from red to green, if I want to modify this change, in such a case, what will happen? I will only be redeploying the front end part. I am not going to be touching the backend and data storage part. So if you will see here, we have different layers and these layers can communicate with each other over a network. So that is how we can go ahead and scale our application. When we are going to be separating these layers, we can still work on all of these things, correct? And when we are going to be working on all of those things, that is going to be independent of each other. We, let us say we are getting some load on the front end. So instead of scaling the entire one, we can go ahead and selective scale only one part. So if we will have to scale the front end, we do not have to worry about the backend or the database. So this is going to be reducing dependencies and this will make it easier for us to make some changes or add some new features. Now, if you talk about it, here all the layers are independent, correct? And they can communicate over network with each other. Now, the backend service which we are having here, that can be reused by the other applications also. Like, let us say in our application, front end is something which is mostly used. And backend we have written some of the logic which can be used by different applications, not just by that application. So that is something which we can do, right? Similarly, let us say in the data storage, we are storing some data which can be consumed by two different applications. So what we can do, we can go ahead and share it. We can reuse it. So in simple terms, we can say that SOA is going to be making the application more flexible, scalar, and easy to maintain by separating it out into different parts, and we can allow each of these parts to work individually. Now, let me just quickly take that example which we have discussed when we were talking about that Amazon cart, right? So let me just quickly take that part. Yeah, this is the one which I was talking. Let's just go and take it. Just saving time so that we don't have to draw it all over again. Yeah. So now, if you look here, what we were actually doing, in this case, we had a user and that user was making use of this entire service. So now with the help of this example, we are going to be understanding why do we have to use SOA? What are the advantages of that? So here, I'll list down all those advantages as well. Now, what is the most, just now I told you one thing, like let us say you are getting more load on the front end. So what you will do, you will go ahead and scale that part. So what is the first advantage which we see here? That is selective scaling. So with SOA, you can just go ahead and make one part of the system bigger, or you can say you can just go ahead and scale one part if it is getting too busy. So if you talk about this entire setup, so like let us say in this one, this payment service is actually getting so many requests because it can happen. Like let us say it is some sale time, and in such a case, people will be placing multiple orders. So in such case, this payment service is something which is going to get too consumed. So if this payment service is getting too much request, in that case, you can go and make just that part scalable. In that case, you are not going to be touching the remaining services. We are only going to be touching the payment service. So this way we can go ahead and save our money and resources as well. The next advantage of this is, like, here we are keeping all the three components separate. So if we will be keeping all of the components together, in that case, we will be having tight coupling. But if we are going to be keeping all of these components separate, then we are going to be achieving loose coupling there. So when you talk about SOA here, we act like, the different parts, the front and back end and data storage. So they do not depend upon each other. If you are making some changes in the front end, so only front end is going to get impacted. The rest one are going to be untouched. So that is how we can say that if one part or one service is going to change, like in this case, let us say I only want to make some changes in the checkout. If here something is like, or let us consider here something is breaking, it is not working. So in that case, it is not going to affect the others. It is just like a team where everyone is just playing their own game without worrying about others. I can also take the example of a classroom setup. Let us say you guys are watching some video online, some online classes there. Let us say one person is losing its network. In that case, it will not happen that everyone will stop watching the video. Only that person will be impacted. So that is how it is actually going to be working here. Yeah. Now we will be looking into the next advantage of SOA. So the next one is faster deployment. Now, like I said, that let us say I want to only change the CSS part. In that case, only front end is going to get redeployed. We are not deploying the entire application, since in this one we are dividing our system into smaller services. You can go ahead and update or deploy just one service instead of the whole system. So that is how it is going to be making all the updates faster and easy. The next advantage of SOA is more flexibility. So when you talk about SOA, so here it is going to be letting you use different technologies. Here you can go ahead and use different programming languages or tools for the different parts of the system. Like if you talk about like let's come back here. If you talk about one service, like let us say we are talking about authentication service. Let us say here I want to use Python. If you talk about inventory service, let us say here I want to use Java. If you talk about shipment service, let us say here I want to write the code in C sharp. So that is how, if you will see, even though this is one project, but I am breaking down all the services into different languages based upon my requirement. That is how I'm adding a flexibility. So this flexibility is allowing you to pick the best tool for each job. If I will feel that, okay, in the authentication, I will be running more scripts and Python is making more sense. So we can just go ahead and implement that service in that programming language. So that is how it is going to be there. Now, the next advantage is your agile development. If you remember, when we were discussing monolithic, I clearly said that here you cannot go ahead and apply agile here. And that is because of the tight coupling. But here, if you will see what we are doing, we are breaking the entire system into smaller services. So different teams can work on different parts at the same time. And this is also going to be helping the project to move faster and be more flexible to the changes. Now, like, if you talk about all of these advantages, so these were typically the disadvantages which we had in our monolithic system. And because of because of those disadvantages, we came up with SOA, which actually overcame all of those challenges which we were facing there, and it turned all of those challenges into its advantages. But again, this is also going to be having some of the challenges. So let's discuss what are the challenges of SOA. So, what is the first disadvantage? That is overkill for small applications. Now, let us say I even took this example. Like, let us say you're building a small application. You are only doing the POC, proof of concept. In such a case, SOA might be too much, because in such a case, you are going to be setting up multiple services, multiple networks, connections, and all of those things are going to be adding some unnecessary complexity and cost for the small project. So whenever you are building a small project in such a case, if you are proceeding ahead with monolithic architecture, so that is going to be making more sense. Okay. Now here we are going to be having high latency. Or we can also go ahead and say that here we will be having some slower communication. Now what will happen, like if your application is actually requiring some fast response and low latency, in such a case we should not be going ahead with SOA. Now why? Here I told you we are going to be having some different components which will be interacting with each other over a network. So if a client needs some data from multiple services, they will have to talk to each other over the network. And each service has to send some requests and responses across the network, which can be slower as compared to a monolithic application, because in monolithic everything is in one place and they can communicate with each other more quickly. So here the extra communication which we are building between the services, because they are at different locations and we are communicating over network, so that can increase the time it is taking to process a request, and that is actually going to be resulting into higher latency and slower performance. Now the next disadvantage of this is complex security. So if you talk about security, if security is something which is your top priority, where security is utmost important, in such a case, you should not be using SOA, because here, generally, you will have some limited resources, and with those limited resources, it will be difficult to manage everything, correct? When you talk about SOA here, we will be having multiple separate services which are going to be communicating with each other. Now, every service is going to be secured individually, correct? Now, this is adding complexity because each service requires its own measures, just like everywhere we are performing some authentication and authorization. So if we are having more services, that means we are going to be having more points to secure. It means we are going to be getting more chances for the things to go wrong, and more security risks can also be there. So this is going to become complex, time consuming, and expensive to manage. So because of this, we can actually have some security breaches as well. So if security is your concern, please avoid SOA. The next one is difficult to test. Now here, like let us say we are having one application and that application is requiring some deep testing, some thorough testing, some simple testing. If such a case is there, in that case, we should be avoiding SOA, because when you talk about, in SOA, what exactly we are having? We are having a distributed system where all the services are distributed, all the components are distributed. So in such a case, testing such a system is going to be complicated and challenging, because SOA is going to be having multiple services which are going to be running on different servers or machines. So it will become harder for us to check if everything is working perfectly or not whenever we are going to be testing. Now we are going to be discussing, one example based upon the challenges which Instagram faced. Okay. Now I'm just going to be discussing one of the scenario. I don't know how many of you actually noticed, but this is something which happened sometimes back. So, if you guys remember, there was a time frame where Instagram was down and it was all over the news. I guess this was back in 2021. I vaguely remember, but it was quite it was down for quite a lot of hours. Now I'll be discussing what exactly happened and why we encountered such a situation. So, Facebook is a global leader in the technology. And what Facebook did, it acquired Instagram. So when they acquired Instagram, they faced some unexpected testing challenges. So even though if you talk about Facebook, so here also we use SOA, and in Instagram also we use SOA. So even though both of the companies are using service oriented architecture, so Facebook is still is a top leading, you can say, a large scale, a global distributed organization that already developed some of the custom testing engine. Okay, so the Facebook already had some custom testing engine. So why they were using it? Because they knew that we are growing in our size and they wanted to ensure that they have stability of its system. So that is why they came up with this custom testing engine. This Facebook testing engine was developed so that they can perform integration testing across their distributed system. This tool was intentionally, with the help of this tool, what they were doing, they were intentionally bringing down one machine down at randomly. And with that, they were testing how well the system is handling failure. So if we have some multiple machines, so out of that one, they were intentionally putting it down and then they were saying if that is happening, how the rest two are going to be handling that failure. So what Facebook did, Facebook deployed its service across multiple machines, and all of those machines like these ones, so they all are connected over the network. So during testing, the engine randomly shut down one machine just to ensure that even if one server fails, the rest of the application should continue to function smoothly. And why they were actually doing this? So the primarily aim, the primary aim behind this was to make sure the application still remains operational even when individual parts of the system is failing. So this was helping that is Facebook highly available or not. And while we were checking it, if you talk about the social media applications, what is the one thing which we look in such applications? That they should be highly available. If we are bored, we just want to open the application, we just want to scroll down there. So what we want as a customer, that it should be always available. So when we apply this kind of testing, so that is going to become a complex testing framework, which correct, because it is quite complex. Generally we do not do such things, but here we have introduced that complex testing framework so that we can maintain high availability and we can minimize downtime. We can maintain high availability and we can minimize downtime. Now, what actually happened when Facebook acquired Instagram, he thought that whatever custom testing engine we have here for the Facebook, let's apply the same testing engine to Instagram infrastructure as well. Because they thought that they both are using the similar architecture, so it will be pretty much similar to apply the same testing engine here as well. But it did not go smoothly as expected. When Instagram also used SOA and had global presence, it had not developed a similar robust testing infrastructure. So what happened once the Facebook testing engine was applied to the Instagram, it randomly took down several nodes in the Instagram network. So here we were only doing it down for one, but in Instagram, more than one got down. So as a result, what happened? Instagram was down for 4 hours. You can say more than 4 hours. Okay, so because of that, we had that huge downtime, which actually became a major embarrassment for the company. And why it actually happened? So the root cause was that Instagram had not properly tested their distributed system in the same way Facebook had. So even though Instagram followed SOA, testing a distributed system, especially with multiple services and nodes, is quite complex. So without an effective testing setup, issues can easily arise that might not be caught or easily go undetected until they affect live production system. So all of these things can actually happen even in SOA. Okay. And here, we have discussed this difficult to test. Now the next disadvantage is more confused developers. Now, previously in the monolithic, we were only using one technology across. So every team was just focusing upon one technology. But here, if you will see, we are using multiple technologies. So when your team has less experience, or if your team is not familiar with a lot of technology, in such a case, we should be avoiding SOA. Because in SOA, different services may be built using different programming languages and technologies. Like I said, it can happen that one service might be using Java, another one might be using Python, another one can be using C sharp. So this can be confusing for the developers who are not familiar with all these technology. So if your team is not experienced in managing multiple tech stack, it can be hard to keep everything running smoothly. Now, another disadvantage which we have here is constantly changing communication protocols. Now, let us say you do not want to deal with the complexity of evolving technology. In such a case, you should not be proceeding ahead with SOA, because what happens in SOA, you are going to be having some front end, you are going to be having some backend, you are going to be having some data storage. Now, if this backend wants to communicate with the backend, how it will be doing over the network, correct? But here, what initially people were using in order to have this network communication. So previously they were using soap there. Okay, because what they have seen over the period of time, the ways in which services were communicating with each other, that has changed. So previously we were using soap. Soap means simple object access protocol. All right, but this has been largely replaced by REST. This REST actually stands for your representational state transfer. All right. And eventually, this got even replaced by gRPC. So, in this one, like what gRPC is, that is your Google Remote Procedure Call. So, like everything is evolving, even how we are going to be making the communication, that is going to be also be changing with the time. And recently this grcp is gaining more popularity for its performance and advantages. So if you are using SOA, in that case you will need to keep up with these changes in the communication protocol. Whenever we are going to be making some shift in the technology, that is going to require you to adapt your system and possibly update your code so that you can stay compatible with the new standards. So if you are having some of the projects that do not require this level of complexity, or it is not going to be involving some constant updates, in that case, the frequent changes in the communication protocols can be a headache. So the efforts which we are going to be needing here to keep up with the evolving changes, that can become difficult. So I hope you must be clear with all the disadvantages. Now I will be quickly discussing what is the difference between the microservices versus the monolithic architecture. So, when you talk about microservices, so that is something which is becoming a buzzword. That is something which is becoming a hot topic because that is something which everybody is just talking about. Everybody is just hearing about it in the tech industry these days. So people will be mostly like, talking about them like they are the like, these microservices are the next big thing. So they talk about that it is the future of the software development. And people will also be asking questions like, are you working on microservices? Or are you still stuck with monolithic? Like people are going to be asking certain questions as well. But trust me, you do not need to feel that microservices is the good choice and monolithic is the bad choice. It is important to remember that both microservices and monolithic architectures have their own strengths. We have just only discussed what are going to be the strengths of SOA and what are the strengths of the monolithic. Like we have also discussed what are the disadvantages for the same. So depending upon the use case, we are going to be picking that. Okay, so there is nothing to feel like microservices is the best solution. Each approach works well in different scenarios. So both architectures are going to be useful in the different scenarios. So is microservices really something new? So let's check if it is something like, a new term or something. So let's check if it is worth the hype or not. So when you talk about microservices, this is what? This is nothing but the more advanced form of SOA. You can say the SOA got evolved and it turned into microservices. So is microservices really a new technology? So microservices are not a brand new idea. It is nothing new. So in fact, like, these are the advanced or the evolved forms of SOA. In order to understand this, let us think that how human civilization has evolved over the time. We started from somewhere and over time we are evolved and developed new ways of doing something. Like initially, if you talk about the human civilization, so initially we had monkeys, then we had some early mans, then we had some humans. So you can see over the period of time only the human civilization has happened. That is how this human civilization has happened over the period of time. Similarly, if you talk about this situation, so this microservices, so that was also something which has already been there in the form of SOA, and then SOA has evolved into microservices. Now, the main goal of SOA is to break the application into smaller, and more manageable parts where each part had a single responsibility, just like how we have our single responsibility principle. So, microservices are simply more granular version of SOA. It means they take the idea of SOA, break it down into smaller and more independent services, because what generally happens if you have a bigger application, of course that is going to be adding more complexity. So what we do, we just try to break it down so that it is going to be more usable. Now we are just going to be seeing how microservices are different from SOA. So like, let us say that in SOA we are having three services: service 1, service 2, service 3, and these services are communicating with each other over network.
All right. So here, if you will see, since they are communicated over network, so this is also going to be adding some dependency there, correct? And because of that, like, if you will see in SOA, what we say that we are going to be having different services and each services should have a single responsibility. And they, like, if they want to communicate, how they will be doing over the network, correct? So when you talk about SOA, what we have done here, like we tried to add some flexibility. We said that a service one might have its own database, like, we'll be just extending this only. Like, since we are having three services, this part is still, like, they are communicating this way. Now what we will say that it can happen that these both services are going to be using same database, and this service can have its a separate database. Now, even though each services are independent, they can still share a database. So if S1 and S2 are sharing a database, we can say that they can have, like, if S1 is writing, they can actually have some performance issue. How? Like, let us say if S1 is writing something to the database. In such a case, S2 can experience some slowness. S2 can experience some performance issues because they are somewhat dependent on each other. The shared resources means there is still some coupling, correct? And even though they are separate, but still they are going to be having a dependency there. So this is where microservices take a different approach. Yeah, so now let's see what happens when you talk about microservices. So in the microservices, the rules are going to be little much stricter. So if we have three services, S1, S2, and S3, they will be 100% independent of each other. Every service is going to be having its own database, like no sharing. And every service is going to be having its own lifestyle, and that should not be dependent upon the life cycle of another service. So this means that each service should be able to start or stop or update without affecting the others. So when you make services that is independent, you achieve a higher level of granularity, you achieve flexibility. So microservices would require that each service should be fully isolated with no shared database or dependency. Each service can be scaled, updated, or deployed separately. Here we actually have complete independence. With the help of that, we ensure that there is going to be no impact between the services. So if S1 is going to go down, in that case, S2 and S3 will still run to continue smoothly because they do not rely on the same database and resources. And here, like, everything still they are connected with each other over the network. But the major thing is they are not sharing any of the resources. They all are acting like mini applications. Here we have three mini applications. So here we can say that although they are connected, but these three are actually going to be separated from each other. All right. If you really want to understand it in the terms of some real life example, what you can consider when you talk about SOA, let us say you are having two siblings and each of one them is given a toy by your parents. Like, for both one item we are giving, okay? Because since they are siblings, so parents usually think that they can share that toy. But what happens if one person is using it, the other one has to wait? If the other one is doing, the first one has to wait. They can even have issues there. They can even fight over that, correct? Similarly, when you talk about the same in SOA, services might share a shared database, and one service action can affect the performance of the another. So that is how SOA is going to be there. Okay. Now, if you talk about microservices, what will happen? Even though you are, let us say, you are twins, you and your sibling, you both are in the same class. But if you talk about school, generally schools are very strict in these terms. There the teacher is going to be expecting that both of you will be bringing your own notebook, your own set of materials. So every student should be having its own resources and nothing is going to be shared. In similar way, if you talk about microservices, so each service is going to be having its own resources and it is going to be independent from each other. So I hope this must be clear to everyone. Now we are going to be meeting in the next module. Till then, happy learning. Bye bye.